In the last episode, we covered the electron arrangement within atoms. Today, we will still stay on the topics of electrons, but we are going to do something differently. What we are going to do today is that, given an atom, we will try to fill in all the electrons of the atom into its shells, subshells, and orbitals. So we are going to put electrons into an atom. That's what we're going to do. Even though we have learned a lot about electrons last time, however, to do this, to complete the job that we have today, we still need to know a little bit more before we can do that. So rules for assigning electrons. Number one, electron subshells are filled in order of increasing energy. Okay, this one tells us electrons, when you put electrons into an atom, you want to put them into the lowest energy level first. After the places are occupied at the lowest energy level, you move to the upper energy level. Taking this opportunity, I would like to make one thing clear to all of us. All the particles we're going to learn in this semester, molecules, atoms, electrons, their behaviors may differ greatly, but there's one thing in common for all of them. They always try to stay at their most stable energy level. All right, so let's move on. Electrons occupy the orbitals of subshell such that each orbital acquires one electron before any orbital acquires the second one. Okay. Electrons in such singly occupied orbitals must have the same spin. Well, if by reading through this, if you understand what it means, that's good. If not, let's talk a little bit more about this. They're talking about different orbitals in the subshell. So I'm going to use subshell P as example. I'm going to draw 3 boxes to represent 3 orbitals in the P subshell. And this one talks about the electrons occupy them and talking about the direction of the spin of the electrons. Okay, all right. I'm going to use an arrow up, pointing up or pointing down, an arrow like this to represent the electron, the arrow pointing up or pointing down to tell you the 2 electrons may take different spins. So the arrow direction tells you the direction of spin, either counterclockwise or clockwise. So what we're going to do, we're going to put electrons into these orbitals by following this rule. Okay, first electrons come in, takes an orbital. I assume it is taking that spin. The spin direction is that. Then it tells you now when a second one comes in, the second one will not pair up with the first one. The second one will take a different orbital. And such singly occupied orbitals must have the same spin, or not only a second electron will take a second orbital, but it will have the same spin with the first one. Now in this case, if the third one comes in, the third one is going to take another orbital. Same spin. That's what rule number 2 is telling us. Number 3, no more than 2 electrons may exist in a given orbital. We know that. We learned that before. And then only if they have opposite spin. Okay, now if electron number 4 comes into one of these orbitals, it has to pair up with one of these. Which one doesn't matter, but it must take the opposite spin. All right, this is 3, basically the 3 rules we have to follow in order to do this today. As a matter of fact, by following rule number 1, we can accomplish a lot of this. The last 2 rules will only be needed when we talk about orbital diagrams at the end of this lecture. Let's move on. All right, we have already clarified that electrons will fill in the subshells in the increasing energy order. Well, we know something about the energy level. Okay, we know that shell number 1, overall shell number 1 will be in a lower energy level than shell number 2, number 3, number 4, number 5. Overall, it goes up in energy. However, even if we mentioned that before, but we didn't know exactly the energy levels of the subshells. Okay, starting from shell number 3, number 4, the energy level of the subshells start to overlap. The example here is 4s in shell number 4 is actually at a lower energy level than subshell 3d in shell number 3. So we have this energy order of the subshells. Well, maybe we cannot remember this right away, but let's use this diagram. Let's have it in front of us. Let's try to fill in the electrons in its subshells of an atom. Let's use bromine as example. Bromine has 35 electrons. Let's try to put the 35 electrons of bromine into its subshells. Let's see what are the subshells that are occupied by those 35 electrons. We're going to do this together. All right, the first electron comes in. Where is it going to go to? Of course, it's going to go to shell 1, subshell 1s. We filled in the subshells from the lowest energy level. Okay, this is how we write it. We'll say 1s. Okay, 1s can hold how many electrons? 2. Okay, we are going to use a superscript, upper right, to tell everyone, okay, in the case of bromine, 2 electrons will go to subshell 1s first. Once the 1s is filled up, where the next electron is going to go to? Of course, 2s. All right, I'm going to write 2s here. And how many will stay there? Okay, it can hold up to 2. We have way more than 2. We have 35 altogether. Now 2 are in 1s. We have 33 left. All right, so 2s is going to take 2 now. After 2s, electron will go to 2p. 2p will hold up to 6, remember? And we have way more than 6, so 2p will take 6. Next, 3s is going to take 2. 3p is going to take 6. Okay, let's keep counting, keep a track of how many electrons we have put into their places. We have 2, 2, 6, that's 10. We have filled in 18 electrons, but we have 35, so we still have a lot more to go. All right, after 3p is filled, the next subshell will be 4s, not 3d. All right, so 4s is going to take 2 as well. S can only hold up to 2. Well, I'm running out of space. Ideally, I'll keep writing next one's 3d here, but I don't have enough room. I'm going to write it here below. So next will be 3d. 3d can take up to 10. Do we still have 10? Let's see. We have 2, 2, 6, 2, 6, 2. That's 20. We have 35 minus 20, which is 15. Well, we have way more than 10. So 3d will be filled up. 3d will take 10 electrons. After the 10, 15 minus 10, we have 5 more to go, okay? We're almost there. After 3d, then we'll go to 4p. 4p can take up to 6. However, we have only 5 left. All 5 will go to 4p. We are done with all the electrons of bromine. This what we just wrote here tells us all the subshells that are occupied by electrons for bromine atom. All right. So these are the subshells that are holding electrons. It tells us not only which subshells are filled with electrons, but also tells us how many electrons are in there. Make sense to you? Now let's talk about electron configurations. Electron configuration is a statement of how many electrons an atom has in each of its electron subshells. Oh, that sounds exactly like what we just did. It shows us how many electrons an atom has in each of its electron subshells. Electron configurations are not written out in words. Then what it is it written out then? Electron configuration of bromine. Let's look at bromine. What is the electron configuration? Oh, that's exactly what we had on the last slide. Okay, what we did is we configured all the electrons of bromine into their corresponding subshells. What we did there, we wrote out the electron configurations of bromine. Well, this is the way our book uses to write the electron configuration of bromine. If you go online or look at some other study materials, you may see that some of them are written in this way. The difference is the sequence of 3D and 4S. Okay, sometimes people group all the shell number 3 together. Okay, well, regardless which one you use, when you write it in this way is the sequence. The electron configuration is written in the sequence of the subshell that is being filled. All right, even if you write it this way, you need to keep in mind, you need to be very clear that although 3D is filled after 4S, however, 3D is in shell number 3, it is closer to the nucleus than 4S, which is in shell number 4. All right, if you see this one, you need to be very clear that even if 3D is written ahead of the 4S, however, it is filled after the 4S subshell. All right, overall, that's how you write the electron configuration. What we did, let's review what we did. What we did is that we followed the subshell energy diagram where they have 1s at the bottom goes up, all the subshell energy levels. Then we keep filling in electrons to them until we used up all the electrons of that atom. Or some of you may claim, okay, with that energy diagram of the subshells, I can do that. However, it's not very easy to memorize that energy levels of different subshells. If that is hard for you to memorize, maybe this one can help you a little bit more. Okay, this diagram shows you the sequence of all the subshells that are being filled. It starts from the upper subshell with an arrow. The arrow tells you the sequence of all the subshells that are filled with electrons. 1s, 2s, followed by 2p, 3s, 3p, 4s, 3d, 4p, 5s, blah, blah, blah. So even if you don't memorize this one, I think you can easily draw it out by yourself. This is not too hard to memorize. Orbital diagrams, what is this? orbital diagrams shows you how many electrons in each of the occupied orbitals. The one we wrote the electron configuration earlier, it shows you the number of electrons in each subshell, but it doesn't tell you the individual orbitals. All right, give us an example that again, I'm not so clear with what you're talking about. All right, let's look at an example of the orbital diagrams of oxygen. This oxygen is element number 8. So it has 8 electrons, and if you follow the procedures we did with bromine, you will complete the electron configuration of oxygen. This is the electron configuration of oxygen. To draw the energy diagram, to draw the orbital diagrams, this is what you will do. You first laid out the subshells that has electrons in it. Okay. Then you draw empty boxes to represent the orbitals in those subshells. S subshell has only one orbital, S subshell has only one orbital, P subshell has 3 orbitals. Now you start filling in those 8 electrons into them. The first electron is going to go to 1s. Again, I use an arrow to represent one spin direction. Clockwise, counterclockwise, I don't care. Let's use upper arrow to represent the direction of spin. The next electron, again, is go to 1s, but it must take an opposite spin. That's what we learned at the beginning of today. If an orbital takes 2 electrons, the 2 electrons have to take opposite spin. Okay, so 2s. Now 4 electrons in the 3p orbitals. The first one takes an orbital. The second one comes in, is going to take a different orbital. This is the rule number 2 we covered at the beginning of today. Electrons will take different orbitals before they pair up. And when they do that, they will take the same spin direction. All right, second one. The third one, number 4 comes in. Number 4 has to take an occupied orbital, now has to pair up with one of them. Which one, it doesn't matter. However, it has to take a different one. You take one of them, and it will have the opposite spin of the electrons currently in that orbital. Okay, that is the orbital diagram for oxygen. Okay, a quick practice question. How many unpaired electrons are there in an atom whose electron configuration is that? Oh, the electron configuration is that. That's just what we just practiced, oxygen. How many unpaired electrons are there? 2. Okay, 2. Okay, 2 electrons are unpaired in the atom oxygen that has the electron configuration of 1s2, 2s2, 2p4. What about 1s2, 2s2, 2p1? Okay, 1s2, 2s2, 2p1. Let's draw 2p here. 2p1. Oh, there's only one electron that is unpaired. What about 1s2, 2s2, 2p2? 2p2. Okay, 2 electrons are unpaired. 2p3. 3 electrons are unpaired. 2p5. 3, 4, 5. Only one electron is unpaired. Make sense to you? Exercise. Draw the electron configurations of each of the following. Okay, so 2 practices here. Sulfur, barium. When a question like this appears, your job number 1 is to decide how many electrons you have to take care of. How many electrons you need to put them into their subshells. How do you know that? Periodic table. Find sulfur. Sulfur is element 16, so you have to put 16 electrons into sulfur, into different subshells of sulfur atom. Barium is element number 56. So it has 56 electrons. You're going to put 56 electrons into the subshells of barium. All right, try to do it by yourself. You can use the energy level of the subshells, one of those two charts that we covered earlier. Look at that and fill in the electrons into their subshells. You can pause the video right now and do it. After you're done, come back to check the answer keys. Here is the answer key for the two items. Hopefully you got them right. If not, don't be discouraged. It's not that challenging. You can do it. Just practice a few more. You will be an expert on this.